Oh, here we are back with the test for in this case, for this example, a population variance, which is similar thing, same thing for a test for a standard deviation. It's just basically how you write the hypotheses. And let's go about this. Again, we're going to find, hopefully you've seen the pattern here now with the one proportion z-test, the one sample z-test for a mean, and also a one sample t-test for a population mean. So, we've been around here three different types of tests for three different types of parameters. One p, well, actually two parameters. The other mu, or the average. It's just that the z-test isn't very practical in terms of real life situation in most instances, almost everything. And so the t-test is being used in place of that one sample z-test. But anyway, here we're going to use a chi-square test. And sometimes these are tests for, we can use f-test to test for equal variances and stuff, but we're testing for a specific value here for the population variance. Okay, so here, the scenario is we have a sushi restaurant, and they do give you the mean here. And we don't really need that for anything that we're going to be doing, but they do give the variance, okay, which is just the standard deviation squared. All right, so that's to be 24.7. So I guess maybe data they've collected over a number of years. They say over the years, they don't specify the years, but we're going to assume it's a long time, and they have a pretty good handle on that. Now, they want to see if the variance is going to have any effect if we use a new menu. Okay, so they take a random sample of 19 of those customers who ordered from the new menu. All right, and that's important that, again, it's random. And the new variance rating is 44.3, which is quite a bit higher here. All right, so we're going to assume the ratings for the customers who order this new menu follow a normal distribution. So again, that gets back into those conditions in order for these, they tell you that they hold, but I think in class the other day I went over how to why those were, and basically those conditions have to hold just so that your p-values are accurate, that your probability, or in other words, your probability model is appropriate to use, because the test statistics, if these conditions aren't met, won't follow those distributions. Okay, and that would throw the probabilities off. So let's go ahead and start entering some things in here. And notice we see the keyword here, differs, in the question. We want to know if it's different. So I'm not sure if it's going to go up or down before we collect those data. So I'm going to start off here with the equals, like I always do with the null. But in this case here, what I'm going to have to do is, since I just have a sigma here, I got to use this little guy over here. Let me try that. I want to get that on the other side. Okay. So let me go back and do the equals and click in here. Okay, so I'm going to use this one here, and I'll put the sigma squared just so that's how I'm going to get that. And the 72.5. Oh, nope, I'm putting in the mean. That should be 24.7. All right. And down here, we want to know what differs, so we're going to do the not equals. Okay, so I'm going to come back here and use this. Okay. All right, so they kind of guide you through here. We want to use the numbers of degrees of freedom. And again, we're going to go one less than the sample size here. We're going to see on our spreadsheet back here that we're going to get all this information in order to kind of go and enter all this in here. Okay, so we are selecting enter the number of degrees of freedom. Let's just come down here and just show you that if I do this, so obviously I'm not collecting the T template now. It is on now the variance and standard deviation test. Okay, so up here is the confidence interval deal, and we're going to go here with the sample standard deviation. Okay, Now, they don't have a place to enter the variance. Okay, so you have to remember that I need to take the square root of the variance or the standard deviation is the square root of the variance. Um, so what I'm going to have to do with this one here to enter the standard deviation is take the square root of the given number here, which is the variance. So I'll do that on this calculator here. I'll take the square root of 24.7. All right, and I hit enter. So that is going to be 4.9. Let's call it 70, because we're going to round to 3 decimal places. So 4.970. All right. Oh, wait. I hypothesized value. I don't know. Sorry about that. I should be entering that in here. So the sample standard deviation, I think they gave us, wasn't it? They gave us a sample variance. Yeah, 44.3. Sorry about that. That should have taken the square root of 44.3. So let me do that. Excuse me for that sidebar there. Okay, so let's round that to 3 decimal places. So we'll say that's 6.656. Okay. So I'm going to come over here on my spreadsheet and 6.566. Let me make sure that I did that right. 6.656. I didn't. 6.656. And my hypothesized value for sigma. Okay, so yeah, I have to, I should have just typed that in there. So I'll have to take the square root of 24.7. So let me clear that out. So that is going to be 4.970. Okay. Okay, so again, not to throw you off here, confuse you, but this spreadsheet calls for putting in the standard deviations. Okay, so I went ahead and did that. And I just need to make sure I have the correct n in here, which we have a sample of 19. So I just need to change that. And the significance level up here, probably 0.05 as usual. Okay, so there we go. So they give us our degrees of freedom. They give us our test statistic. And they also give us the two-tailed p-value. Okay, so all this stuff is kind of given for you here. So let me kind of drag this over here so that I can get this out of the way. And so we'll just start punching this stuff in here. So our degrees of freedom, it's 18. We're doing the two-tailed test. So notice they, and by the way, these chi-squared distributions, they're not symmetric like the normal and the t. These are actually skewed right. And the lesser the degree of freedom, the greater the skewness. Okay, so if I had like, let's say this isn't correct, but let's say if I had 2 degrees of freedom, well, they want 3. Okay, so you see how skewed that is. Okay, and then if I go to like say 7, and then if I go to like 8, you can see that the skewness is kind of going away here, but for us, we need to go to 19. Okay, I think you can see what happens once n gets so big, it actually becomes essentially normal. All right, but let's put our test statistic in here, which is a 32 point. And they want this to 3 decimal places, so it's going to be 284. 284. Okay. All right. And notice what they do here is they actually go ahead and find another value of chi-squared because it's two because it's a two-tailed test. Now, where that's coming from, and it's automatically doing this for you here, but the actual mean of the chi-squared distribution is going to be the degrees of freedom. And so, the idea is, well, if we find the area to the left of this chi-squared statistic, we also have to find, match up the area to the right. So it's like this area is going to be the same as this. I know they don't kind of look that way, but remember this one kind of tails off into, forever. And so these two areas are going to be equal. But so when we add those areas up, the spreadsheet does that for us for the two-tailed test. They add up to be 0.040. So, just, to let you know that, how this stuff, kind of comes down here. The test statistic here, the p-value for the left tail. And this is kind of weird, but they're using this value over here. So this would be the 97, it looks like. So this right tail area is going to be 0.02. And this left tail area over here is going to be 0.02. Whatever that is, that change, and add them both together, we're going to get this. Okay. So I know that seems a little bit confusing, but I like the fact that they do have this picture here for you to work with. So I'm going to put in my 0, 4, 1 decimal places, right around 0. Okay, so I think I did that. So my p-value is 0.05. Notice, they tell us if they reject, they have a logical test down here, but I still like to, just make sure, we go up here and say, yep, 5% p-value is less than that, so we reject. So obviously we're going to select one of the first two, right? Because our p-value is less than that. And since we rejected, the first indication says this, that we would reject it. This will be the false answer, right? Because p-value is less than that. So that's just wrong. Okay. So anyway, I think we addressed everything here. I filled in all the blanks. So what did I do here? I must have forgot something. Oh, my answer for B is incorrect. What did I do? I must have did something here. Well, that's odd. It says that my test statistic is at 32.284. Oh, I see what I did. I'm sorry, I mistyped that. That's 18 degrees of freedom. Sorry. Okay. So let's recheck that again. I think I got everything else in here. Okay. Yeah, sorry about that. I just mistyped that here. I don't know, I must have been daydreaming or whatever. That should be 18. Okay. You get that right from here. It should be one less than the sample size. So that's why I was wrong. I typed the 19 here. Okay. But everything else is correct here. All right. So, like I said, these are kind of a little bit easier to manage because you have this diagram to work with here. So, I'll tell you what, let's try another one, just see if we can find one with this one had the variance. So let's find one with the standard deviation in it. That's a variance here. Let's try another one here. Yeah, here we go. Standard deviation. Notice we still have this bit down here. So records indicate that the mean weight here is going to be 1.7, and our standard deviation is 32 kilograms. All right. So we're talking about oxygen depletion from pollutants going into a creek, and we from Western Pennsylvania, you say correct. But anyway, the biologist has 15 that they measured, and they noticed that the standard deviation is 0.43. Okay, so we're now inferring about the standard deviation. All right, so again, the only difference here now is we have to type in the values. They're just using sigma and not sigma squared because we're talking about the standard deviation. So we put up our hypothesized value, which is that, and the effect we're looking for here is differs. Okay, so we got another two-tailed test, so I'm going to go ahead and put it in that. And 0.32. Sure, I'm typing everything in correctly here. All right, so we're going to get the rest of this stuff from over here. So let's just make sure. I'm going to probably have to toggle back and forth because every time I click the spreadsheet, this is going to wipe out. So let me try to get some things squared away here. So we got the 0.32 and the 0.43 and 15. Okay, so this time we don't have to take square roots. So I already forgot the sample. What was it? 0.43. Okay, so this goes to 0.43. This was 0.32. Our sample size was 15. Change out to 15, and our significance level is good old 0.05, which is probably the most popular one. Okay, so we go ahead and put that stuff in there, and we're done entering things over here. So now let's come back here and type this stuff in. So we've got our degrees of freedom here, which are 14. This again is a two-tailed test, and it's kind of funny, you know, the other one said, you know, perform a two-tailed test. I don't see that written in here. So that's kind of odd. It does for some of your problems. I was doing it for, I think, the t-test, but not this one. Okay. And we enter our test statistic here, which happens to be 25.27. If I round that, third test we placed at 9, so that's going to be a 9. All right, and so here again, it's going to come over here and give me the complement of it. And again, where that is coming from is in order to get this area to match this area, okay, we figure out how far this is from the mean, and then we move over this much. Now, you know, in practical sense, all we have to do is double this to get the p-value, right? If we just were able to find that and just double it, we really don't need this additional value of chi-squared, but because these two areas are equal. But anyway, we're going to go ahead and type in this p-value for the two-tailed test, which is 0.064. 0.064, just make sure I rounded correctly. Okay, so there we have that, and our level of significance is higher, right? Or I'm sorry, lower than that. It's 0.05. Just double check here. Yep. Okay, had that over here too. Could have just looked over there. All right, so we're not going to reject. Okay, so again, our p-value is greater, so we have these to pick from, and here it says there's not enough evidence, right? We're not rejecting. Support that alternative, okay? And this is, you know, differs, so that would be the correct one here, okay? So if the p-value was less than 0.05, we would have picked this because there would have been enough evidence, all right? So scanning real quick, I think I did everything else over here. Oh, I forgot to shade the graph. I didn't. Okay, so we do that. So now we can check that. And there we go. Okay. So, you know, we got that one correct there. And that's essentially how you do that. Again, just scanning down the solutions here. Went over how to get all those values in there. And the rest we're pretty much just reading from this spreadsheet here. Okay. Um, just to kind of reinforce the fact that there are other options over here, for this, finding these areas. For instance, I can find the chi-square greater than. Slide this over, so pick one here, so I can just type it in. Greater than 25.279. And with 14 degrees of freedom. Okay, so if I hit enter, this number right here should match this one, which it does. It's just this one has more decimal places, so it rounds. We could do the same thing in Statlet. I'm not going to go ahead. You get the idea with that one, but there is a tab or a calculator there for chi-square densities. All right, so that's that one. There's really only one more type of problem I think we need to go over here. And unless you guys have questions, you can always email me or whatever. But let's go back and let's just do one of these with the critical value method. So, and I'm just going to do one of these. So whether it's variance or standard deviation, we'll see. So here's a mean. We're dealing with records from an electronics company that show that it rejected an average of 1.7 circuit boards per batch. I'm not really sure what the batch contains in terms of number, but there's their standard deviation of 0.59. So we're going to be dealing with the standard deviation here. The fact that those are kind of nice because the spreadsheet's set up, you don't have to do all the square rooting to get the, when they give you the variances. But anyway, here, so the factory suspects that now it's using a new molding process, and therefore it's going to up the standard deviation. And so they get a random sample of 12 batches, and they find that the standard deviation is 0.2 or 0.81. Okay, so that's their sample standard deviation out of 12. So we want to assume that the number of circuit boards is approximately normally, so the conditions all hold is, so we're using an alpha of 0.10 here. So let's begin the typing. So as always, our null hypothesis is equals. So we will come over here and I'll type in my sigma. And I'm sure we put in 0.59. Since now we're looking for greater than, it's probably indicated that, we'll have this be 0.5. All right, and we are using the chi-squared statistic. And so now let's find the value of this statistic and degrees of freedom and all that good stuff over here. So we're going to go to our spreadsheet. So I'm going to slide this over so be able to toggle kind of back and forth here. All right, so let's go with the sample standard deviation. So that is 0.81. Okay, so I'm going to put that in here, 0.81. And this was 0.59. And our sample size was 12. Change this. And our significance level was 0.1. Okay, not that we need that right now for this. So go back here and wipe all this out and put in the point. I'm going to check it again. It's all 81 in there. Yeah, okay. All right, so at least for the right tail, okay, we got a p-value of 0.03, so we should reject it, okay? So that p-value is less than that. We would be done at that point, but of course, this being an ALEKS problem, we have to use the method that they want us to use, and that is the rejection method. So what we're going to do here is put in the value for our chi-square statistic, which is 20 point, I guess they want this 3 decimal places, yeah. So that'd be a 733. Okay, and now let's find that critical value. All right, so we can use this calculator to find the chi-squared with a critical value of 0.10 to the right of it. So I would just put in 0.1 and the degrees of freedom 12 and hit enter. And there's my 18.54, which again is less than that, which would make more sense, right? I mean, we don't have a picture here. I'll go ahead and look at one here just so we get this all down. But so that's how you get that. So let's just remember that 18.549. I'll type it in right here. Okay. All right. So, and of course, our statistic is beyond that, which means our p-value is less than 0.10. Okay. And we know that it is. It's actually the p-value is 0.03. Okay. So, so can we conclude it's greater than that? Absolutely. We do have enough evidence because, again, our test statistic is beyond the critical value. Okay. So that means the p-value for this is going to be less than the p-value for this. And we know the p-value of this is 0.10 because we just found it here. Okay. So let's see how we get the 18.549. We want to find a chi-squared value given a chi-squared area. So if the right tail is 0.01 and our degrees of freedom are 12, or no, 11, like they are over here, here's the 17.275, which is what we have in here. No. Did I use the wrong one here? I may have. In the, let me see, degrees of freedom 11. I bet you I used the 12 here. Let me go back and use that calculator again. Just to, so I'm going to slide this over and change this value to 17.275. Okay. You can hear my dog there going. So let's slide this over just so see all this on the screen at the same time. So let me go back and do that just to show you. I probably did that. I was looking at the wrong number over here. So let's put in the 0.1 and also now put in the correct number, which is 11, and hit enter. And yeah, there we have it. So I must have typed the 12 in last time. So I apologize for that. And hopefully some of you were screaming at your screen, although I couldn't hear you because this is a recorded. But anyway, the we could see that that statistic is greater than that. Okay, so so if I would just take the 17.275 and come over here to now the chi-squared distribution, just so you can see a picture of this. And let me put the 11 in here. Okay, and we're going to the right 7. 275. Calculate that area. There's our 0.1. So if I show those labels here, like that, and if I get back here, okay. All right. So here's what we're saying. This value here, 20, is out here, right? So if I go to the right of where my floating arrow is here, obviously the area to the right of 20.7 is going to be greater than that blue area, which is 10%. Okay. Now, again, we knew that over here because we just looked at, you know, the area to the right, which is 0.03. Okay. So, you know, if I did change that value to the chi-square statistic, I'm going to get this 0.036. So we'll do that just for fun here because we're already here. So I went to the wrong one here. So let me just make sure we get the right chi-squared statistic. It is 20.733. So if I change this to 20.733, okay, you can see that there's that 0.0362, which is the same as what we had here. Okay. So, you know, we knew right then when we typed that stuff in to, you know, definitely reject it, but, you know, using the technique over here off of this one here, if I would have gone back, to that 0.10 area over here, we knew that this area was going to be less than that. Okay, so that wraps up the tests for a population variance or standard deviation using this. Oh, I didn't check it. So, and of course, I have some empty boxes. So what did I not check here? Yes, no. Oh, that's why I put the wrong degrees of freedom in. That should be 11 here. Okay. So, okay. So anyway, we're correct here. All right. So that's how you do that one. And so really just summarizing what we did is we basically took a look at tested significance for population proportions, population means. You were given two techniques, two different tests to use. But again, like I said, the z-test for mean really isn't that practical. And in practice, we, research and so forth, we use the t-test. And then finally, the chi-square test for checking or testing population standard deviations and variances. And I tried to touch on both techniques within each test, which is a direct p-value versus the critical value method. And hopefully you got a pretty good handle on all of that stuff. So, all right, so I'll get this stuff up here. And as always, it's been a pleasure. God bless you guys. And remember, next week, I'm not going to be at class live. I'm just going to post videos like these. So, it's pretty similar to what's going on in class anyway. So I guess I'll kind of see you then next week. So God bless you and have a great Easter.